Students, today we are going to learn partial correlation. Before you learn partial correlation, you must be studying multiple correlation and Karl-Pearson correlation coefficient. Already I have made these two videos. It is available in the description box. Go through that, students. You are going to get the formula, definition, and many examples I have solved on that using the calculator. Yes, students, today also I'm going to use the calculator. You can see on the screen I'm going to use the calculator, and easily we are going to calculate the partial correlation. So today we just seen what is definition of partial correlation, formula for partial correlation, and very important, using calculator we are going to find all the answers. So without wasting your time, let us start. What do you mean by partial correlation? We are going to see here. Partial correlation is a method used to describe the relationship between two variable, whereas taking away the effects of another variable. So you can see very easily there are three variables, two variables. We are going to find the relationship. Third variable, it is not going to affect this two variable. That is a very simple concept we have. In case of partial correlation, one studies three or more variables, but consider only two variables to be influencing each other, and the effect of other influencing variable being held constant. So you can see, suppose there are three independent variables. We are going to take two independent variables relationship we are going to study. Third independent variable, we are going to keep it constant. So very important topic we are going to discuss today. Watch the video till the end, students. If you like this video and is helpful for your examination, please like and subscribe this channel. Yes, students, thank you so much. So we just continue. A partial correlation coefficient is a measure of linear dependent of a pair of a random variable from a collection of random variable in the case where the influence of the remaining variable is eliminated. So you can see we denote partial correlation coefficient by R, where we can see linear dependent of pair of random variables we have taken in this example, and another remaining variable we are going to eliminate it from this partial correlation coefficient. Now you can see we study the partial impact of second variable on first variable. Suppose second variable impact on first variable, then please remember the third independent variable we are going to held constant, and which is denoted by R12.3. Very, very important. You can see a capital R 12.3. We are going to say this is partial correlation of second variable on first variable. Third variable, independent variable, is constant. Similarly, we study the partial impact of third variable on second variable, keeping first independent variable constant, which is denoted by R23.1, which is, we can see third variable impact on second variable or second variable impact on third variable. First independent variable remains constant. Similarly, we study the partial impact of third variable on first variable or first variable on third variable, keeping second independent variable constant, which is denoted by R13.2. So remember, students, R12.3, R23.1, and R13.2. We are going to consider this as partial correlation. So we just see the formula here. Yes, here we have the formula for partial correlation. So R12.3, which is equal to R12 minus R13 into R23 divided by square root of 1 minus R square 13, 1 minus R square 23. Similarly, we have partial correlation R23.1 is equal to R23 minus R12 into R13 divided by square root of 1 minus R square 12 into 1 minus R square 13. So this is in the square root. Please remember this, friends. Okay. R13.2 is equal to R13 minus R12 into R23 divided by square root of 1 minus R square 12 into 1 minus R square 23. So you can see these are the formulas of partial correlation coefficient. Please remember this, ones, practice this formulas. Now we are going to use this formula to solve the example. Very, very important. Watch the video till the end. You can see where R12.3, we always say this is partial correlation between x1 and x2. Suppose there are three variables x1, x2, x3, then we take R12.3 as partial correlation between 1 and 2. Suppose in the exam they may also ask only to find a partial correlation between x1 and x2, you have to take only this first formula and simplify. Okay, next we have R23.1, partial correlation between x2 and x3. Similarly, we have R13.2 is partial correlation between x1 and x3. So like this we have the three formulas. So next, we should also know, or we should also come across total correlation coefficient. Whenever we are solving partial correlation, we require total correlation. What is total correlation, students? Yes, it is for a given set of n random variable x1, x2, x3 till xn, then the total correlation C of x1, x2, x3, xn is defined as the joint distribution f of x1, x2, x3 till xn to the independent distribution of f of x1, f of x2, f of x3 till f of xn given by r12, r13 and r23. Remember this one, only the role of 1 2 will change, 1 3 and 2 3. You have to manage this properly. If you take r12 total correlation between x1 and x2, so meaning of that x1 and x2, then which is given by n into summation x1 into x2 minus summation x1 into summation x2 divided by square root of n summation x1 square minus summation x1 the whole square into square root of n into summation x2 square minus summation x2 the whole square. This is total correlation between x1 and x2. Then r13 is nothing but total correlation coefficient between x1 and x3, which is equal to n summation x1 into x3 minus summation x1 into summation x3 divided by square root of n into summation x1 square minus summation x1 the whole square into square root of n summation x3 square minus summation x3 the whole square. Similarly, we have the r23. It's a correlation coefficient, total correlation coefficient between x2 and x3. Remember this formula, friends. If you don't understand, then revise this. Hello friends, today I am going to teach you partial correlation. Before studying partial correlation, you should watch the video of multiple correlation and Karl-Pearson coefficient correlation, which is there in the description box. If you like this video, please like, subscribe and share with your friends. Right? So today we are going to study partial correlation. What is the definition, formula, and very important, using calculator. I am going to teach you very easily, meaning 5 to 10 minutes you can learn partial correlation coefficient. Yes, students, watch the video till the end. Dear students, if you like this, please, if this video is helpful for your examination point of view, please like and share with your friends, let them also pass the exam. I can see I'm going to consider here three variables, x1, x2 and x3, where you can see that x1 is the number of score in math subject. I will take this score as x1, and x2 I'm going to take the student scored in physics subject. I'm going to take this as x2, and x3 is the number of students in every class. Suppose A, B, C, D, they have given E, then these are the number of students present in their class, and these are the score they have obtained. Now immediately you have to go to the table. You have to take x1, x2, x3, and you have to take all these values. So you are going to take x1 square first, find x2 square, x3 square, then x1, x2, x2, x3 and x2, x1, x3. This is x1, x3. So x1, x2, x2, x3, x1, x3. All these values I am going to calculate using the calculator. So without wasting your time, go to the calculator, students. Yes, it is x1 square. So 36 square. We have 1296. I'll write here 1296. Right. Next, I'm going to take x2 square, 38 square. So 38 square, or you can take 38 square here already there on the calculator. Just make equal to 1444. So I'll take here 1444. Similarly, go for x3 square, students, 45 square. Okay, so I'll take 45 square on the calculator. You can see it is 2025. So here I get the value 2025. Next we have x1 into x2. Yes, friends, x1 is 36 into x2 is 38. The answer is 1368. So it is 1368. So x2 into x3, it is 38 into 45. 38 into 45. Let me calculate on the screen. You can see, which is equal to 1710. So here we get 1710. Next, similarly, we have x1 into x3. So on calculator, it is x1 into x3, 36 into 45. So here we get the answer 1620. So I'll write here 1620. So like this, you have to simplify all these values. We get, of simplifying all this, squaring the values and simplifying, we get here, friends, this table. Okay. Now immediately when you get this table, friends, first you have to substitute all these values in the calculator, taking on the screen. Here we have go to more setup, then press 3 button. You can see you get statistics. In this statistics, we are going to take the correlation between two, x1 and x2. I will take first. I will take over to x1 and x2. And I'm going to type all the values: 36, 30, 40, 50 and 78. So n we have 5, right? 1, 2, 3, 4. You can calculate easily. There are 5. Y value I'm going to take here x2. So 38, 42, 38, 68 80. So please try this once. Practically you try in the calculator, right? Then press AC, then go to shift 1. Yes, we take the 3. Here we can see summation of x1 is 2. So summation of x1 we get 234. So this I will take the summation 234. Now again shift 1 3. I want summation x2, so I'll take here summation y I have considered as x2. So it is 268. I'll take here 268. Now never add this column, students. You have to do it in the calculator. Okay, then summation x1 x2. I will get summation x1 x2. Go to shift 1 3 5 x1 x2. Summation x1 x2 is 13,944. I will take here 13,944. So here like this we get the all the data. Is it clear? Again we have missed x1 square. So let us take this shift 1 3. Summation x1 square is 1. So I'll take x1 square equal to 12,380. So let us take here 12,380. You get the values on the screen. You can see you get the value. Similarly go to x2 square. So shift 1 3 3, which is equal to 16,000. Yes friends, we get 16,000 exactly. So this is 16,000. Okay. 16,000. Right. Okay. So here we see we have completed the data. Okay. Now I'm going to take the correlation between x1 and x3. So here also it is x1 and x3. I will get here. Very easily we are going to calculate x1 and x3. Go to the calculator once again, friends. Yes. Again take mode setup 3 2. You will get again x data and y data. Type all the x data 36 30 40 50 70 80. Now you take x3, right? 45 55 64 62 35. x1 and x3. Now go to shift 1. Forgot to type EC. EC you type first. Okay, then shift 1 3. x1 square you know, so we'll go to x3 square, that is 3. Yes, y2 is nothing but x3. So equal to 14,000. No. I think you have taken summation x3 square. Correct, it is 14,215. So take here 14,215. Now shift 1 3. I want 4. That is summation x3. Yes, summation x3 is 261. This is 261 I got. Okay. So everything you get it on calculator. Just without wasting your time, you have to substitute and simplify. Okay, I just made one more. I will tell you what I've done. Okay, next we have x1 and x3. x1 and x3, what you get? Shift 1 3. x1 and x3 is summation 5, which is equal to 11,660. Here we have 11,660 x1 x3. Am I right? So this data we have filled. Now all these values you have to substitute in the calculator. You will get the answer. Yes, let us try this. X2 x3 is there. I will tell you afterwards what to do with that. First we'll fill up this data. So first I am going to take a summation. Total correlation coefficient you have to calculate R12, R13 and R23. Write down the formulas properly and substitute the values immediately when you remember the formula. Here I am going to substitute the values. Okay. N, please remember what is N. So here you can see 1 2 3 4 1 will start from here. Sorry, 1 2 3 4 5. So N is equal to, we take 5. Okay, so here we take N, small n we take normally, capital N we don't expect. So this is 5. Just take here 5 into 5. Summation x1 x2. Summation x1 x2 is 13,944. Summation x1 is 234, and summation x2 is 268. Similarly here we have 5. Summation x1 the whole square. Summation x1 the whole square is 12,380. and again summation x1 square 234, then here we have n 5, summation x2 the whole x2 square, it is 16,000, then summation x2 square, x2 the whole square is 268. So all these things you have to put it in calculator. I will show you how to get the direct answer. Easier the video screen. So now I'm going to calculate the next value. Again, substitute the values here, friends. So here we have n is 5, so take down 5. Summation x1 into x2, x1 into x3 is 11,660. Summation x1 234, and summation x3 261, then divided by n is 5. Summation x1 square is 12,380, and only summation x1 is 234, the whole square it is, so I will keep as it is. So all the things you are going to substitute in calculator, but I will show you directly, you will get the answer. Summation x3 square is 14,215, and what is summation x3 is 261, the whole square. So just now we have calculated and substituted all the values in the calculator. Summation x1 r13 I have taken first column and the third column, all the data I have taken in this. So you have got, so directly I will take shift 1, will find the correlation coefficient directly on calculator within 2 seconds. It is 5, and here we go 3. It is correlation coefficient minus 0.603855. So this answer we get here. So this is our equal to minus 0.6038. So here we get the answer, friends, R13 directly from the calculator. Yes, friends. So like this we get the answer. Is it clear, friends? Now similarly okay, little bit takes time, word file, right? It will take time to calculate. Okay, now similarly you calculate R12. So you want to fill up the data x1 and x2 to get R12. I will show you directly. So go to the table once again, go to mode setup, statistics, take 3, 2, x and y get. So type down 36, 30, 40, 50, 70, all the data I have typed for x1, and now I will take x2, 38, 42, 38, 68, and 82. Now press AC. Directly in one step you will get the answer. Shift 153 equal to. So this is correlation coefficient 0.9169. So just take here. This is equal to 0.916965. Okay. So I get the correlation coefficient R12. Here I have correlation coefficient total. This is only we are finding correlation coefficient. Is it clear, friends? Please remember this. Still we have to find partial, that I will show you. Here I get R12 and R13. Similarly you have to try for R23. So second column and third column you have to type. So go to shift, go to table, sorry, go to mode setup, 3, 2 to get x and y. I will take here x2 and x3. So just type the values 38, 42, 38, 68, 82. Okay, then take x3, 45, 55, 64, 62, and 35. So all the data is been filled, x2, x3. Then press EC. One data is missing in the table, you can see. So I want summation x2, x3. So I'll go to shift 1, 3, and 5. If you miss anything, friends, please rewind the video once again and watch the video once again. So equal to 13,538. We'll take here 13,538 I get directly. So press again AC. I will find the correlation coefficient directly. Shift 1, 5, 3, and press equal to, it is minus 0.4594. So I will take this here, R13. Here I have, so directly substituting the values, friends, I will get the answer minus 0.4594, minus 0.4594. So like this you calculate R12, R13 and R23 in calculator directly. Next, after finding the total correlation, please remember you have to substitute in the partial correlation. Please write down the formula properly, students. And now we'll substitute all the values in the calculator. Here in this case we have to substitute all the values. So let us substitute all the values. Okay, here we have 1, 3. So all the values are 1, 2, 1, 3 are the answers. I will just take down here below. Therefore, we have R12 is the answer and R13 is the answer, and last we have R23. So these values we have calculated. So substitute all these values in the calculator, students. Easily you will get the answer. So here substitute all the values. Okay, quickly you have to do it, but it's taking time. Okay, no problem. R12 substitute here 0.916965. okay, you can take 4. That is enough. It will take 96. Okay, this much is enough, so that it will not be much complicated. So here we have minus, I'll take in bracket. It is minus 0.60385. Next into R23, I'll take it in bracket because whenever minus is there, I'll take always in bracket 0.494. Then this is square, R13 square. So this value you have to take the square, right? Then R23 square. So this value you have to take it square. So like this, remaining values also you have to take it. So this is what we get the substitution. Now you can put it in the calculator. So let us type it in all the values in the calculator. So here we goes. Press again on. All the data has been filled. Mode setup 1. So you will come back to the original position. Now we'll take the values. Divide 0.9169 minus, please take the bracket always, minus 0.60385, close the bracket, into next bracket minus 0.4594. This is all the values you have to calculate, students. Please remember, here we have square root, so square root is on this calculator. The square means it will go right. This square means this value will become plus only. So minus will become plus. So I will take directly this terms. Okay, take it in calculator. I will take again in the bracket 1 minus 0.60385 square. Square is on the calculator, so just take the square. Bracket completes. Next bracket 1 minus 0.4594 square, and close the bracket. Easily you will get the answer, students. It is 0.90322. So here we have the answer 0.90322 is the answer. Similarly, you have to substitute and get the answer. So directly substitute in the calculator. No need of writing once again. So just bring the calculator here. I will just press once again on. Now I will take the divide. Here we have R23. So R23 is minus 0.4594 minus R12. R12 is plus only, so I have nothing to do. 0.9169 into R13. R13 is minus, so I'll always put minus in the bracket. Whenever you are using calculator, you should be very careful. Then go to the square root. Again, bracket is there, so please take the bracket properly. It is 1 minus R square, R12 square. So 0.9169 square is on the calculator. then again take 1 minus r13 square. R13 is in minus, so square means it will become plus, so 0.60385 square. And yes, here we calculate r23.1, it is partial correlation is 0.3961. Here we get the answer, students. Similarly, you try for this one. In calculator, you can go to again on, divide once again. You can see r13 they have given here. On this, you can see r13. R13 is minus, so I'll take minus 0.60385 minus r12. R12 is 0.9169 into, whenever minus is there, students, r32 or r23, they are same, one and same. As minus, so I'll take always in the bracket and divided by the square root. Square root is on the calculator, square root. Bracket is then take bracket 1 minus r12 square. Square is again on the calculator. So just take square root very easily. And r23 square is minus square. Square of minus is plus only, so I'll take same value and not change anything. Just take your square. And this is equal to minus 0.515, some changes. Okay, so here we get the correlation coefficient minus 0.5151. Get here 5151. This is how we get the answer, students. And thank you so much for watching. If this video is helpful, please like and subscribe, and please share with your friends, students. Thank you so much, and all the best for your examination. Thank you so much.